Hey. Hello, everyone. Thank you so much for coming. We're excited to host this session on the practice of informatics and pathology. Just as a reminder, the session is being recorded. We want to thank you all for your attendance, and we hope that this session is educational and answers some of your questions about informatics in pathology. My name is Jenna Ungst. I am the president of PathSig, as well as a third-year medical student at LMU DCOM in Knoxville. And I'd like to invite the other members of Virtual PathSig who helped plan this event to introduce themselves.
Well, hello everyone. My name is Daniel Masonette. I'm a fourth year at Pecan, Georgia, applying into pathology. Very nice to meet everyone.
I am Ting Xiao, and I am one of the event co-chairs. I'm a third-year medical student interested in pathology at MUCOM in Indiana.
Hello, everyone. My name is Julia Chen. I'm one of the social media co-chairs. I'm a third-year medical student at New York Medical College and interested in applying into pathology next year.
Hello, everyone. My name is Pranitha. I'm a current fourth year from ARCOM who has applied for pathology this cycle.
Hi, I'm Taya. I'm also a social media co-chair, and I'm a second-year student at CCOM.
Now we'd like our guest speaker, Dr. Chamala, to introduce himself.
Okay, good morning and good afternoon to all of you. And thank you very much for all the board members for inviting. My name is again Srikar Chamala. I'm an associate professor at USC, University of Southern California, in Department of Pathology. I also work at Children's Hospital LA, where I'm the director for Pathology Informatics and Data Science. So today, again, I come from informatics background, learn pathology, and doing more pathology informatics practice. So I'm going to share today some of the practical application of pathology informatics, so informatics in pathology practice. So again, it would be really high level, some of the topics, and the expectation is it's not like you're gonna know everything, but just a high level, just whatever you can get, absorb it. And it can provide you a guidance for you in the future when you go to residency or even now, right? Even if you're in a medical school, you can start preparing yourself some of the basic informatics coursework or something for you to prepare to practice informatics when you go to pathology departments and stuff. With that, I think anything else you want to go, I can start my presentation. Okay, I think we have 13 members now. So maybe I just want to type S in the chat message if I just want to see how many of you already have an informatics background. That is, you did a programming course, even in the high school, don't worry, even in the high school or undergrad. How many of you did, maybe I'll type it here, just like it, okay? How many of you had a computer coding experience? Sorry, the spelling is wrong, but yeah. Just like it if you think, a thumbs up. If any of you have a coding experience. Okay. Couple of them. And how many of you are from engineering or computing undergraduate major? Can you also tell me how many of you are from kind of engineering and computing undergrad majors? Even if it's biomedical or something, that's fine, right? Okay. I see not many of you. That's fine. So maybe let's talk this time here now, moving forward. So how many of you, I just want it to be more interactive. How many of you think to do informatics, sorry, to do informatics, you need to have a computer science background or engineering background? Even if you say no, just speak up, yeah. Or yes, speak up also. Okay. So Tracy, you're telling this, okay, that's what you're thinking. The reality is, yes, computer scientists do certain jobs which is important, but it is not something everybody need to know, right? So, okay. So if you're any major non-computer scientist, they can learn programming language or computing in most of the sense, right? It is more of a learning Spanish or different language, right? It is way of communicating with the computer, right? So if you want to communicate with the human, you use certain language. If you want to communicate with the computer, you're going to use different language. That's the only thing, okay? It's more of a logic of if you want to communicate, if you want to frame a sentence, there's a logic the way you use it, right? Oftentimes we learn from a very young age. It's already, the logic is in our brain. But in general, computer programming, and most of the informatics, what we practice in the medicine are, as long as you have logical skills and be able to, if you're a little bit more advanced, try to know coding. Okay. So the simple answer is you need not come from a hardcore computer science or engineering background to become or lead an informatics team in medicine. Okay. So for the rest of the presentation, I will go through some of the responsibilities or roles within pathology, but a similar thing also applies for at the hospital level also. Okay. Let me share my screen here. And also, maybe before I go, one other thing I want to ask you is, how many of you, so, okay, just want to see, why is this presentation interesting to you? What do you want to make out of this presentation? Just want to hear, why is informatics important to you? Just again, there's no right and wrong answer. Speak whatever comes to your mind, Yeah. Any volunteers?
Hello, this is Daniel. I'm just interested to see the future of pathology as far as how AI is going to be put
Okay.
in pathology as a career.
Okay, sounds good. And gain new skills. Pranita, okay, new skills that can help me as a future pathologist. Okay, and I see, okay, sounds good. Yep. Okay. I think hopefully you'll answer more questions once I'm done with this lecture, or presentation. Okay. Again, I wanted to interact you. So today's topic, as you saw from the flyer, is practice of informatics in pathology. This is a very important topic. I think last couple of years with ChatGPT, everything is AI, right? That's what we hear in the news all the time. There's a very good reason why we hear it, and I think that kind of signifies what kind of literacy or pathology informatics literacy we need, not only in pathology but across the medicine to be successful in the future. So we'll have a general overview of informatics and pathology, and I'm going to talk about within pathology, what does the team structure look like, within pathology informatics teams within across multiple departments, and also computing and application infrastructures you need within pathology. And I'll give some examples of informatics operations in anatomic pathology, like digital pathology, and also clinical genomic testing and data analytics, which is also very important. And I'll cover very few slides, maybe 4 or 5 slides on AI in pathology and medicine, and also informatics education and training. Okay. So one other thing you should understand, or I think you may already know, is there's a massive shortage of medical laboratory professionals. Okay. Again, there's some of the news, some of the key news outlets which kind of made this point, or surveys. So you get the point. But there's also, I think all of you are interested in pathology. If you're not interested, if you're not undecided, and I think this is a good slide for you to look at. I think pathology, I think there is, if you look at the shortage, there's a lot of shortage of pathologists, and the workload is going up, but number of trainees and pathologists are not enough to serve or this workload. If you look at even globally, it's much worse. In Africa, there's a number of 1,500 pathologists, per 1.34 billion population. So there is a huge global pathology opportunity also, both to volunteer and also participate, in empowering, pathology workforce across the globe. Again, you see the diagnostic workload, how much it increased. One other thing I want to point out is, can anybody guess how much, if you take the hospital data, right, whole hospital data, what percentage of data is generated by pathology? Any guesses? You can speak up. I cannot see the chart here, but yeah, now, yeah. Any guesses? If you take the whole hospital data, I mean, whole healthcare data within one institution, what percentage do you think would be a data generated by pathology? Okay, Jenna, thank you, 50%. Anybody else, any guesses? 30%, thank you. Okay. Pranati, okay. Yes, it is 70%, close to 70%. Hope nobody's Googling up, right? Yeah, so, or asking ChatGPT. So, yeah, so anyway, that's right. It's about 70%, close to 70% is generated by pathology. So now you see why informatics is much more important, right? Because as a department, as a practitioners, we generate a lot more data than a lot of other fields of medicine. So we should also, once you generate the data, you know what to do about it, how to manage the data, how to utilize the data effective way that you can have better clinical outcomes. Okay, you're still able to see my screen, right? Okay, let's go next one. Possible solutions, right? So the possible solutions for what is shortage of pathologists and pathology lab staff. One of them is education. I think the group, all the board members and this whole group, where we are right now, I think that's what they're trying to do. They're educating, they're inspiring, other fellow medical students to, pursue a degree in pathology or residency in a pathology or career in pathology. So that's exactly what needs to be done, right? And also, give one other thing this webinar particularly is doing is, so we are enhancing the expertise of current pathology workforce, basically through advanced topics. In this case, we are, or specialized topic. In this case, we are using informatics as a one of the topic. So I think this group is, I think that, is doing a great job in that. Thank you all of you for the lot of effort, and this is really needed effort. And other thing is, if there's a shortage, of pathologists in under-resourced facilities, right? If you go to rural places, there may not be so many pathology facilities. So maybe even outsourcing the workload from a resource-limited environment. So to do these things, right? To do education or to do specialty knowledge-based training or outsourcing pathology. How do you do it? By embracing technology innovation. For example, Zoom, right? Is a good example of it. We use the information technology to talk to each other, train each other. We are thousands of miles apart from each other, but we are able to come together and train ourselves, right? So other things is implement robust information systems, integrate automation processes, and build and utilize upcoming artificial AI models and stuff. And other thing is to build and nurture a dedicated global community network or national network or whatever network which can basically enhance pathology education. So how do we define informatics, right? Traditionally, people think informatics means computers, right? That's what we think in general. But that is not true. So informatics is the study of how data is acquired, stored, processed, retrieved, analyzed, and presented in such a way that we turn data into information, right? Having data is good, but it is not useful, right? Once you extract some information from the data or converting data into information, that is where the application is, right? So in before computers came in, right, there were people were doing on the paper, right? So it is still, you can still acquire, store, process, retrieve, analyze, present data using paper. You don't need computers. But what computer does is they're the critical tools which can handle massive data. We can do things faster. We can store a lot of data. Imagine you have 1 million patients in your hospital or in your lab. Can you imagine how you're going to go through papers? It's not possible, right? It's so much of work and so slow. So the computers are critical tools which can enable this. And knowledge of computers is essential, okay? So within pathology, right, so you hear the terms nursing informatics, you hear bioinformatics, pathology informatics, pharmacy informatics, clinical informatics. There are multiple informatics. Basically, based on the radiology informatics, right? Based on the domain, they have, the underlying principles remains the same, but the application differs, okay? And the tools differs. So in our case, we are focusing on pathology informatics. The way I think of it is applying informatics across various pathology sections, right? You can do clinical genome informatics in the molecular pathology lab or image informatics for pathology images and stuff. And you have a laboratory information system informatics and biorepositories, also part of pathology in general. And also you have transfusion medicine that could be specialized, informatics focus there. So overall, I think the way I would like to define is, all the informatics that we practice across, pathology as a department. So one of the beauties of pathology is the diversity of the data. It's a challenge, but also an opportunity, right? So if you look at I think for in my perspective, I think pathology is one of, I think, the most complicated or diverse field. So if you look at this example here, right? Within anatomic pathology, you have autopsy pathology, surgical pathology, you do fellowships in some of these specialties, right? And then within clinical pathology, we have chemistry, hematology, immunology, microbiology, transfusion medicine, flow cytometry, HLA, and at CHLA, we have 20 plus sections overall, okay? So all of them are experts in their subsections, okay? So, and then you have a genomic medicine, which is big, biorepository, how to handle this data, the storing the samples for clinical and also for research purpose in the future. And you can also have precision medicine or genetic counselor sitting in pathology. Oftentimes, you also have a division of experimental pathology, or research pathology. And you also have a lot of regulatory building and HR compliance and all those things, administrative stuff within pathology. So you saw this domain is complicated. And I think as you go for a residency and stuff, you get to explore all of these areas. And the workflow also complicated. There's a point of care testing, secondary opinion services, inpatient testing, outpatient testing, reference laboratory testing, send out testing. So there is a lot of complications within the workflows as well. And external workflows are enterprise data integration, government regulatory agencies, research company collaboration. So that is also another complex in workflows. So what it means is you have this complicated, diverse and complex domains and workflows. So for which you also need a appropriate computing infrastructure, and also tools and the people who can manage these domains and workflows. One of the area is infrastructure, right? How are you going to store the data? How are you going to install your LIS, Laboratory Information System software, and also how you connect them with the lab instruments and how you connect with the EHR. The infrastructure is key. I'm going to discuss more in the next few sections. App configuration, right? You can have EHR and LISS. Basically, I'll talk more about those. And data analytics and configuring lab interfaces so that data could be transmitted from the LIS to EHRs and so forth. And the software app or middleware, basically you also need to build some custom software. For example, you can build a custom databases or AI tools and so forth. So in general, this is something at our institution. We have about 3,500 plus lab tests built. Okay. And if you look working with anatomic pathology, we have 600 plus part types and procedures we need to build in our LIS, and over a dozen LISs, or laboratory information systems. We have about more than 50 plus lab instruments to manage, and we send out our tests. We not only do testing in a house, but we also send tests to external to MyoQuest and other vendors outside. Another thing is, again, we also do outreach, meaning other hospitals send us, tests also, So we need to do training for new laboratory staff or faculty and so forth, and collaborate within PLM across CHLA, enterprise, and external partners. And I also mentioned we develop custom informatics pipelines and middleware. I'll talk about a little bit about what this means later, but not so deep, not so important. But just important thing is we build some custom software, and we manage the computer infrastructure and deploy it, and also we do online on-call support 24/7. So in general, pathology information workflow is in the EHR, the physicians or ordering providers, they order tests, right? And the tests go to, once the tests are on the EHR, which is clinician facing most of the time, right? And it comes and it gets into our laboratory information system. Okay. It says, hey, we received this order from this, from the doctor, and then it shows up in the outstanding list of the particular section. And then the specimen is collected, and once the specimen comes into the lab, it is put to process into the instrument, okay, or on the bench. And then what happens is, there's sometimes many instruments also have middleware. So LIS basically communicates the middleware. Middleware is which communicates between lab analyzer and the LIS, So don't worry about the details of it, but just understand is sample comes in, it goes to LIS, it goes sometimes, most of the time it goes to middleware, and middleware interacts with the lab analyzer and stuff. Once you put the sample in the analyzer, the results go back to the middleware, to LIS, into the EHR, where physician will be able to see it. Okay, this is a general workflow, and this is where our informatics team does, right? Making sure the connections are good with this EHR and LIS and middleware and lab analyzers, and also making data is transmitting properly. It's called interfacing. That's what it is called, official word. Okay. So this is the lot of work informatics team does, to managing these connections and so forth. And the landscape of pathology is evolving so rapid. There are a lot of specialized assays are coming up. The telepathology is a lot of progress going on there. We are generating large-scale data sets. I'm going to show some examples later. And we are also advanced clinical decision support is making right now. and data analytics is becoming a huge importance, because of evidence-based strategies, and there's also multi-institution collaborations, and also we discussed earlier, one of them mentioned that there's AI, is going up, and you want to see what the application of AI in pathology, and also growing demand for in-depth information training, right? With the data, with the more informatics within the medicine and pathology, there is a growing demand for this training as well. So overall, I think by now, I think I presented saying that the pathology is a high diversity and complexity data source are present within the pathology, and it requires diverse computing skills. Okay, so this is a team approach, meaning it's interdisciplinary, interdepartmental, interinstitutional. It is not just pathology, within the pathology. So is very much team across within the pathology, external to pathology, and also across multiple institutions. These are some of the functions we do: education, and integration with the EHRs, or managing LIS, system integrations, clinical management, research and development, data analytics, and telepathology. Okay. So what kind of personnel you need to achieve, right? So my team, contains these three different sets of people. Okay. One of them are, some of the members are focused, are called clinical informaticians. What they do is, they configure, when you buy LIS, it comes with a backbone. Then you have to configure your workflows within the system. And they also develop some data analytics. For example, if you have data analytics tools like Tableau or Power BI, they configure those tools also, and also configure the lab interfaces also. Okay, and these people may not be programmers, or they usually come from a lab background. So these people are more like, they have this data analytic, what do you call, the analytical skills. I think most of us already have, right? If you know how to use, Excel very well, that's all you need, and that already proves that you have enough analytical skills. Okay. Same thing here. That's exactly they do, is they configure these LISs and data analytics tools. And then you need a computer engineering kind of thing, but again, not computer engineering, but a system engineers, or somebody who may not have a computer engineering background. I'm not saying that's expected, but somebody who has this, inclination to, build things, right? To, build infrastructure, and so forth. More like engineering mindset, right? What they do is they try to, manage the storage systems, security systems, or work with hospital IS information systems to, manage those things. Okay. And they also manage lab infrastructure like printers and other things. And then you have people who are more software developer kind of thing mindset, or a scientist, computer scientist mindset, where they develop, software apps, middleware, databases, for storing the data, and AI and ML models. Okay. The thing is, I don't want you to get scared, right? Oh my God, all this are required for me to become a informatician within pathology. The answer is no. You will have a team of people under you who are gonna help, deliver these things. But for you, having a literacy of what these different things are, help you to communicate with them effectively. But not only that, right? In the future, if you're a little more serious about informatics, right, or make a more of a majority of a job leading informatics efforts within a department, this is perfect, right? Because because you need to spend a little bit more knowledge of informatics, but you have support from others in your team who can help execute things. So irrespective of you want to be full-time informatician, or really a good communicator or collaborator with informatics team, still having informatics knowledge is very important. And I don't want to be intimidated by the slide that you need to have all the skill sets needed listed here. Okay, let's go next one. Again, multi-skill, close collaboration, and synergy. So let's go next one. So this slide is busy slide, okay? Don't worry about everything here. I just want you to focus on the first row here, okay? Pathology is a data-intensive field. I'm giving a couple of examples here, okay? Major examples. One is clinical genomics, another one pathology imaging. So clinical genomics, this is the old number, but it's much more higher now. NovaSeq, one of the latest instrument, it can generate 6 terabytes of DNA sequencing data within 44 hours. Okay, and you see the scale of it. And then digital imaging also, the slides, they can generate 700 to 1400 GB of data per instrument if you continuously scan things. The takeaway point here is pathology is continue to generate massive amounts of data and you're going to continue to increase. So what it means is to handle such a large data, you need a good computers, right? With all good RAM, scalable, and all those things, right? So these are five different types of major computing you apply within your day-to-day or within pathology informatics practice. Of course, the personal or desktop computing, which every one of you have access to, right? So this is more your personal laptop or a desktop where you do your day-to-day activities. There's also mobile computing, where you have handheld devices at the point of care testing maybe, or or patient consenting and other things, which are mostly based on cellular networks. And another thing is server computing, okay? Involves powerful computers that provide data and services for other computers over a network. Again, these are, for example, each institution, you may have email servers which are present on these big server computers, okay, because they need to handle a lot of things. Your website services, those are also present there. Some databases. So those are, companies have these big computers called server computer, where they host all these busy services on there. And some institutions have something called high performance computing. These are massive supercomputers with a lot of computing clusters, which primarily used for scientific research and stuff. But I think in pathology practice, I think now things are more moving to cloud computing, So when I say cloud computing, like, you always hear AWS, Amazon Web Services, Microsoft Azure, Google GCI, Google Cloud Infrastructure, I guess, and Oracle Cloud, the multiple cloud computing system, So the beauty of cloud computing is, you just pay as you go, and somebody else manages it. It is stored. You can scale it easy. Today you only need 1 GB, let's say 1 terabyte of RAM. Tomorrow you need 100 terabytes. You just pay more money, you get it. Okay, so you don't really worry about managing everything locally. So this is what I'm just mentioning, right? What is the benefit of cloud computing compared to traditional one? It is fast in the sense that you can buy. I'll get into GPUs and CPUs, larger number of CPUs and also GPUs, which makes things faster, or even the storage, fast storage services, it will make faster. And also they're reliable because managed by big corporations. And recently you heard Azure, Microsoft services went down, right? And I think a lot of institutions got disrupted. There's also downside for it. But again, it's not forever, right? It just goes for 1 hour or something, but that happens even local computing also. And cloud computing is easy and accessible and shareable, with other institutions and stuff, within and other institutions as well. It's scalable, as I'm mentioning you, right? Today you need only 10 CPUs. Tomorrow you want 1,000 CPUs. So you can just pay money and get whatever you want. And unlimited, you can get ton of computing power you need. And it's cost effective because you're not spending a ton of money upfront to build these things, right? You are doing it later. Meaning you don't, for example, if you want to build a huge computing facility, it costs massive millions of dollars. But if you want to go cloud computing, you just pay $1 million a year, maybe, right? To just get what you need. And in the future, you can increase more. And also storage, there's a different tiers of storage. One is cold storage and a hot storage. So hot storage is something where you put files which you're working on right now, right? Or you're going to work in the near future. And if some files you never touch, right? You can have programs where the data could be transferred into a cold storage, which is slow, but costs you a lot cheaper. So those are other tier storage solutions you can apply on the cloud as well. So here, I don't want to spend, interest of time, I don't want to spend too much time here, but there are different models of cloud computing service models. This is a great example. You know, if you think of on-premise, right? On-premise meaning you want to host something on-premise, everything, right? It is like, it's a traditional on-premise, you know, is you make a pizza at home. You know, you dine at home, you buy a soda, bring it to your home, use your own electric gas, oven, fire, pizza dough, everything you can make from scratch. But the next, if you want to use the cloud computing, there are multiple things, something called LaaS, you know, it's as infrastructure as a service. So here, you basically lease, you know, for example, some of the services from the cloud, and rest of it you take care of it. You know, for example, you build your application, middleware, and other things. Okay, so there's something called PaaS, platform as a service. In this case, a lot more things you rent from vendor, and only few things you're going to do yourself. And there's something called software as a service. Basically, everything is provided by the vendor, and you only use the software. Okay, all of them has pros and cons. Here, you can manage, you can control everything. As you go further here, you have less control over things. But on the other hand, as you go left to right, you have less work to do, right? Who want to manage the computers and all those things? I don't want to manage it. I just want to use my application, and that's all I care about, right? So it also has a benefit of, you know, not worrying too much about how to install all those things. I want to show you a quick demo here if it works. Let me see. Let me stop sharing and show you. I want to just show you this demonstration of how the traditional CPUs work and graphic process units works. Have you heard of NVIDIA in the news and stuff? The stocks go crazy, they're going crazy up, you know, if you know it or not. So people who invested maybe 10 years back or something, now they can retire comfortably, you know, without working anything else. Okay, so millions of dollars. So anyway, so I'm going to show you about this, why NVIDIA became so popular, right? Let me share my screen. Okay, are you able to see my screen?
All right, I introduced you Leonardo, and he's going to paint a picture for you guys in the way that is.
Guys, are you able to hear my audio also? My video audio, are you able to hear me?
Yes, Dr. Chamala, yeah.
Thank you.
CPU might do it as a series of. All right, I introduced you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen, Leonardo 2.0. When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10, 9,
8,
7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over.
Okay, you get the point, right? So a traditional GPUs, you do one instruction at one time. This one, if you have a small task which is repeated over and over, you can just give it to GPU. It can do pretty well in parallel and everything. So that's the reason a lot of the AI in artificial intelligence and and for example processing the pixels and the image, those could be done in parallel. That's the reason GPU is all over the place now, and there's a huge demand for that, and that's why NVIDIA and these companies who have this GPU capabilities are in high demand. Okay, let me go to my PowerPoint presentation. So education, again, informatics education is fun, right? You think, if you ask me 10 years back, it's boring. But now there is so many YouTubers, there's so many nice visually explaining how things work. So the point I'm making is you need not have a computer science degree to understand this topic, right? Now, just looking at this nice video, you are able to get what GPU is. If you do a little more read up, you get to know exactly what it is, okay? How it works internally, it doesn't matter. But knowing what it is, how to apply and where to apply, that is what you could be proficient at. So some of the applications of this is whole slide imaging, and you need to process billions of pixels per image. Another thing is Chamala end-to-end secondary analysis, so processing the genomic sequencing data. So as you can see, this is very, very old data. Okay, this is like almost like a 5-6 year old back data. This one, okay. If you look at here, if you use CPU traditional one, it takes 1,200 minutes. But if you use 8x A100, it takes 20 minutes. I think now I'm telling you, this is like about 5-6 years old back data. Right now, things are much, much faster. Okay, you get the point is how fast these things can be made using GPUs in some cases. Okay. Let's move about some of the examples, okay? The informatics examples in AP, anatomic pathology. So anatomic pathology, I don't know how much you know. You generate this tissue, the slides here, and traditionally it is watched under the microscope, and pathology looks at the glass slides under the microscope, and then they make the diagnosis. Okay, this is a traditional path. And I forgot to acknowledge, I put my friend's name, my colleague or my collaborator from Texas Children, Thomas Chang. It's his slide I borrowed from. And next one, if you look at this, this is also from him to some extent. So here, in the digital pathology solution is, you have a patient cases, you scan them first instead of taking the slides manually, slide folder manually and dropping at the pathology offices. You just scan them, and then the pathologist can access them using image management system from their office. So let's think about it. You even on your campus, right? Some campuses are big, right? So if pathologist sitting around, if the histology lab or tissue processing lab is somewhere one corner of the lab, and your pathologist sitting other side of the institution, there's somebody to transport those slides and back and forth, right? Another thing is sometimes you may have a satellite offices, right? And how do you want to ship the slides one office to other? It's just tedious process. And having this imaging digital pathology solution, you can basically scan at one time and where you're processing it, and anybody in the world can access the slides, and a pathologist can diagnose from anywhere they want. Okay. So the point I don't think I need to emphasize more here is, I think things are more going in this direction now already, right? A lot of institutions are having digital pathology. What it means is, in the future practice, things become more and more focused on electronic signouts. May not have microscope kind of approaches in the future. You may still use it, but I think is the need may go down. Okay, and also I'll talk briefly later on the AI solution. Once you have digital slides, you can also apply AI models and everything to automatically diagnose things, right? I'm going to discuss it a little bit later. This is a publication I did around 2020, 21 and stuff. So this is about 10 years back or 6-7 years back. I mentioned earlier in Africa or some countries or even in US, some under-resourced places, right? There are not much access to pathologists to the diagnosis. So this is a simple example here shows in a hospital in a remote place in Africa, they're able to make the slide. They're using iPhone to take a picture of it and put it on the Dropbox or Telegram, all these tools, and upload the files. And somebody in Europe was looking at those slides. This is I'm talking about using iPhones. Okay, you see that the old iPhone you see here, and they're also uploading some of the paper-based scan reports into this Dropbox, and then the pathologists from Europe volunteering. They look over things and then they prescribe some diagnosis to people. So you get the point here, right? It is this is how things have been done in the past. Sorry, even early on with using some primitive technologies. So moving forward, using our cutting-edge digital technologies will not only solve problems within the institution, but also it can help under-resourced regions and countries, to help better diagnosis. Next, I want to go into molecular pathology. I'm going to go through really quick here. Again, it is not that I want you to understand everything here. So many of you know personalized medicine or genomic medicine. Genomic medicine is one of the personalized medicine, right? So as we know, basically based on your genomic profile, we can tailor your medication or prescription or whatever therapy change you want to make, right? For example, based if a patient in their cancer, if they test positive for V600E BRAF mutation, then vemurafenib is the only works treatment of melanoma patients. So this is how people are using now, and for both cancer treatments, germline, pharmacogenomics, and so forth. So this is a key area right now for diagnosis, prognosis, and treatment. Is very much important, and becoming more and more implemented within the healthcare systems. So this is not so much important here. Don't worry about it. Basically, you get the DNA sample, you sequence it, you interpret it, and send it to the physician. Then they're going to change the treatment plan. And sequencing technology and costs are, sequencing technology improving in throughput. So this is what I'm telling you. This NovaSeq X series can generate output of 165 GB to 16 terabytes and a lot more data here. The prices are also going down. If the prices are going down, that means more and more it is feasible for us to routinely use in clinic. So I think here this is not an important thing, but one thing I want to show you is to process the NGS data, sequencing data, there is a complicated pipeline is engaged where informatics is a key aspect of it. Similar to the digital pathology, managing all those systems and storing the slides, pathology informatics is very, very important. Things are also moving from custom development to adapting off-the-shelf softwares. This is an example of a turnkey cloud ecosystem developed by Illumina called Connected Analytics. So let's go into data analytics. So as I mentioned, we have a lot of data, right? The question is how we're going to use the data to make good insights from it, right? Informed decision from the data or data-driven decision making. Here is a busy slide. One thing I wanted to focus is the green are top performers and the orange are low performers. So the top performing companies or businesses often use data analytics to, and underperformance don't use so much. So there's also direct correlation, right? That if you use data, you could get better insights, you can make better decisions, better profits. And again, this is not so much important, but you can do a diagnostic analytics, predictive analytics, meaning what did it happen, based on it, what is likely to happen in predictive analytics, and prescriptive analytics is what should I do about it, and descriptive analytics is what is happening. So these are some things you can do in data, using data, for basically overall it improves outcomes and smart and cost-effective decisions. So this is not so much important. Again, you can build a lot of analytics around it, laboratory test utilization, specimen logistics, test volumes, and also AI ML tools around this data. So this one I'm going to skip here. It's not so much important. Now let's get into AI in pathology. So basically what AI does is it mimics human judgment through software. That's what it is, okay? So the first step is AI systems are trained on data, example images or text data, whatever you have, to identify patterns related to clinical diagnosis and outcomes. Okay, once you have to train the data, then you can you give the new slide or new values. It can tell, hey, this slide shows that this person has this disease, or something like that. So the first thing is training the AI model. Second is applying it to predict, diagnosis or outcomes from the data. And right now there are definitely some models available where we use AI for diagnosis, prediction, and task covered. But again, they're accurate within defined scope, right? And this AI field is rapidly growing currently. And these are some of the examples. I'm just going one example of digital pathology here. You can use it for grading the slides, and then automated detection of mitosis cells, and you get the point. There are a lot of different things you can do. So FDA recently also approved for the page for doing prostate cancer detection, and this tool is helping 70% reduction in false negative diagnosis and 24% reduction in false positive diagnosis. So this field is already there, but only for prostate cancer. But again, as we get more data, more curated data, it's going to expand to other places. Okay. The question is, will AI replace healthcare providers, right? The answer is, I think we'll talk here, the answer is no. So I think you should understand the term called augmented intelligence. What it means is artificial intelligence plus human intelligence, okay? So basically AI enhances but not replaces human healthcare providers, okay? So a combination of using AI tools with the human collaboration is a synergetic workflow which leads higher performances than either alone, right? If I just do it myself, right, as a human, right, I may not be getting, I may miss something, or I may not be fast enough. But if I collaborate with the AI models, AI models lack something, right? And we can bring something onto the table. So if we both work together, there's a lot more we can achieve. The simple thing is, don't think that AI is going to replace humans. Okay, it's going to make things efficient. And other thing is, I think you may have heard of this case, is AI won't replace humans, but humans with AI will replace those without AI. That is where this is very important. Technologies come, they're rapidly changing. As individuals, irrespective in healthcare or business or wherever you are, right? In education, we need to embrace these new technologies, because if we do not, then other colleagues or other people in the field who knows things would be replacing us. Okay. So the point is, embrace AI, harness its potential, and develop and collaborate with some use cases which can help improve the pathology practice, research, and education. So ethical use of AI in healthcare, Again, there's a patient consent and privacy. AI models require a lot of data to be fed into training and everything. So we want to really make sure about patient data, raising concerns about consenting, privacy, and data security, and also how effectively are we de-identifying the data so that we're exposing the privacy. Anybody can build data AI models, right? But thing is how do they validate it? Are they safe, effective, and reliable? Something we need to go through. And that's where the FDA regulations comes into picture. And also mitigation of bias. Let's say, if you're taking data from very financially well-to-do neighborhoods, right? Okay, or some healthcare data, and if you're applying those data models of the AI to another country or another ethnicity or another population, it may not work. It may generate false positive results. If you do not know that your data is biased, you could be misapplying this. So you should be really careful about that. And oftentimes the AI is a black box for many people. That's the exact reason why we should be educating in at least the high level, so that we understand what we are doing. And adoption is other key thing, right? So anyway, so there's a regulatory framework for AI is a key, and FDA is working on, other regulatory agencies are working on this area effectively. I'm gonna leave this slide here, go look at later. The first video here is from YouTube. I'm telling you that you don't know the details. If you go to YouTube and just type AI, or generative AI or GPTs and everything, there are a lot of nice, beautiful videos explained. Okay, this one example I'm showing here is very nice, and there's a lot of scientific publications also around this topic. So this is my last slide here. How you should empower yourself, in this informatics education initiatives, right? So the expectation is not that you do become computer scientist or something. The expectation is, at least the minimum expectation is to gain a general awareness of informatics and AI, and also try to enroll or try to learn a basic computer programming like Python. Okay, which is easy. Anybody can do it. I'm telling you now, kids, 10-year-old, 12-year-olds, they know how to do programming in Python. I think many of you also would have took a course in high school or something, but now things are becoming more and more integrated into the school curriculum. So anyway, so just try to learn basic computer programming. YouTube, Coursera, Udemy, they have a lot of beautiful videos around AI in medicine, GPTs, what does it mean, and so forth. Okay, I'm not spending so much time on that, but just giving inspiration, or at least motivating you to go watch some videos. There are professional organizations available out there. API, Associated with Pathology Informatics. There are a lot of previous webinar recordings or future webinars they have, and they have annual meetings you can attend. Another one is AMIA, Association American Medical Informatics Association. There are also a lot of nice, important things there. Please take a look at them, okay, when you get time. Informatics rotations and courses at your institutions. When you go for residency, you will have informatics rotations there. You should participate in them and collaborate, work in the labs, informatics labs. And if there are courses on the campus, a basic introduction course, a workshop, please attend them. Okay. And once you do your residency and stuff, if you're interested in informatics, you can take this clinical informatics fellowship later. Anyway, overall, the value generation of informatics is it saves you costs. You can make a data-driven decision-making, mitigates errors and misdiagnosis, and it improves accuracy and ease of data sharing, deploys cutting-edge technology and informatics tools like AI. Again, there are a lot more other things here. You can see them. So overall, I think that the takeaway here is AI is key. Not AI, but informatics in general is key for our success. And I think we all need to embrace and at least try to, have something in the back of your mind. Hey, when an opportunity comes in, I'm gonna learn these things. Okay. With that, I'm gonna stop here and open up for questions. Very silent crowd. No questions?
I have a question, Dr. Chamala. So one of the things I observed in the communities or the professional organizations that encourage informatics education, that there's like a bit of a challenge about establishing a baseline, then establishing the updates that you need to keep up with. So what, in your opinion, is a good way to stay up to date with that? I personally tried, say, like being in touch with Python community while I have a baseline of understanding through a couple of EMEA offerings, but things are changing very fast. And what is considered like a state of art at a certain time will become dated, I will say, like in a year sometimes. So what's your advice for staying up to date?
So technologies change, but for example, programming, right? People used to have different programming language before. Now Python is popular, and in the future something else will be popular. But the point is, once you have the baseline knowledge, whatever in the future you want to get, if you want to learn a new programming language, it becomes simpler. Okay. So in terms of getting up to date, for example, I can tell you my own thing, right? I haven't coded so much myself, maybe last several years, a few years, because once you go to leadership position, you have people who can do things for you. And I think as a role of MDs in the future, right? It is not like you're going to go and code things day to day. No, you understand what coding means, how to do it and stuff. Then you have a staff under you who can help you do those things. Okay, so you should get aware of things, how things are changing, but it is not. Initially, you may do hands-on, but later, as long as you are aware, that's all matters. So, so anyway, you get the point, right? So I think other thing is participate in the like-minded people, right? So for example, I have a weekly meetings with other colleagues, other institutions. Okay, participate in API, Associative Pathology Informatics, or EMEA. There are multiple. These groups are there. They have weekly meetings or bi-weekly, monthly meetings where we can discuss things around, right? So I think main thing is you associate with people what you want to become, right? If you want to become a business person, you do not want to associate with pathologists, right? You want to go associate with some venture capitalists, other people, right? So I think form your community and the peer community and stuff, and engage with them. Any other questions?
Thank you so much.
You're welcome. Yeah.
Good afternoon. Thank you so much for this presentation. I am Dr. Hizia. I live in North Carolina, applying for pathology this year. And actually, I am very surprised about how things are going very fast in pathology field. We're kind of talking now about going 100% digital, signing out cases electronically. Not like my dream of being pathologist is I always see a doctor with a microscope, and now this picture started to be replaced by a monitor and a beautiful picture there. So that's like a dream becoming true, actually. So doctor, I want to know, since I have like 7 months before starting any residency the next year, and I know that I'm very interested in digital pathology, informatics, artificial intelligence, it seems like they are one thing. I want to know what to do best during this month, because I really want to be integrated. I'm like, I know what's going on, and I really want to do something serious. Like I want to know how to do it. I want to know what to learn to be the best candidate. I want to know that my fellowship would be something related to digital pathology and informatics. So please give me an advice, guide me, because it's totally new, and we don't have so much guidance. Thank you.
The two things, right? One is how to use the tool is one aspect, right? That is also I'm telling you, it's not easy. When I try to talk pathology informatics, sometimes like there'll be like other faculty. There's a generational gap sometimes, right? If people are like not used to technology, they're like, oh, I'm comfortable with the microscope. Even the process change, from microscope to digital itself is a huge change management in general. So one thing is, don't push it back, rather embrace it. Okay, if you have opportunity at your current institution to do a digital sign outs and stuff, try to practice in that, learn it, understand it a little bit more, understand the process, right? What are the challenges? Hey, what are the downsides of digital pathology? Can the image go bad? So those kind of things. When you go do the what you call a rotation from the starting of the scanning the slide to the end to the LIS, integration and everything. So when you talk to informatics, they can tell you a lot more information. There's a lot of information online also. There's a digital pathology consortium and other things. They have a lot more information. And there are also workshops there, okay? If you look at API, Association of Pathology Informatics, and also Digital Pathology Association, they have DPA. They have routine workshops. You can attend those. And one thing, that is if you want to use them and implement in your institution, right? If you want to go a little bit step further, right, where you want to do some research within this area, right? Learn some Python programming. There's ton of online resources for Python programming, or your institution may have some already available resources or classes available for you to take. Explore that, okay? Or take online. Email me if you're interested. We can have a private chat. I can definitely help you some courses and coursework with you. Okay, I kept my email address in the chat box, and I'm happy to help you. But the thing is, if you have time, 7 months or something, focus on Python. Watch some YouTube videos on what is generative AI. There's some coding you can do also there. So just try to get inspire yourself. I would say that's what I would say. And when you go to residency is busy, but you can get some time to do collaborate or work under somebody informatician there in your wherever you're going to apply.
Thank you so much. Yeah, I am in the DPA, Digital Pathology Association.
Awesome.
I went to the workshop at Ohio State University.
Last month, right? With Anil Parwani.
Yeah.
And that's good. Yeah.
It was amazing, actually. And I'm doing workshops now, watching these things. And Python, there is many courses online. Is there like a course that relates Python in medical healthcare?
I teach the Python course online here. I mean, not online, but in institution. But again, email me private. I'm gonna let you know if there's some I'm gonna pull some for you. Okay.
Okay. Thank you so much.
No problem. Anybody have questions? I know I went over time. Apologize for that, but yeah.
Dr. Chamala, I have a question regarding EMR knowledge. Do you think it's valuable, especially that a lot of us are training either like in med school affiliated with a hospital that uses certain EMRs that can offer modules to get comfortable with workflows and have a deeper understanding of how physicians interact with the EMRs and how to improve them. Do you consider it a good investment of time to maybe pursue some certifications or self-proficiency pathways or things like that?
Absolutely. That's a very, very good question. Oftentimes pathologists, they sit in their office, and that's all they care about, signing out cases. But sometimes most of them, they don't understand how it is impacting the patient, or at least, front end are the physicians, how is it impacting physicians in terms of ordering the test, and what are they receiving back? Are they able to interpret properly, or are they applying some clinical decision support tools around it, right? Are they interpreting it properly? Oftentimes, for some of the tests, especially genetic tests and stuff, clinicians don't know what test to order. We can whole exome sequencing, whole genome sequencing, panels, pharmacogenomics. There's a ton of tests. They don't even know which one to order, and they oftentimes also misorder things, right? Because you can use EHR to help guide physicians, what to order, what not to order, have a good naming convention there. It's easy for them to look at the test and they know what it means. So there are a lot of ways you can also put alerts, right? It's called clinical decision support, where you can say, hey, if the patient already been tested for CBC 12 hours before, for a particular scenario, you don't let them order it again within 24 hours, right? So those kind of restrictions you can apply on the EHR, and where we as a pathologist can help, help them guide those rules and everything. Okay, but not only that, how to interpret the results when they get the results back. Are they making interpretations correctly and so forth also. The second aspect is, yes, you can shadow, you can collaborate, within your pathology informatics team, or with the clinical informatics team in some of these, lab utilization or quality improvement projects and so forth. Okay. Another thing is there's also definitely coursework. For example, there's a physician builder courses. There is the lab builder courses. So go, I think it requires some money, a few $1,000s, but hey, if you're interested, there is always express your interest. Somebody will pay for you within your department, and you can learn, either in residency or in fellowship or something. But definitely, I would really support understanding the EHR perspective of things, because ultimately that is where we're getting the data from, or getting the orders from, and sending the final data to, right? Yeah, good question.
Exactly.
Yeah.
So thank you, Dr. Chamala, for giving such a fantastic presentation. For the interest of time, I want to be respectful to start concluding the session. And thank you again, Dr. Chamala. And we would like to extend a special thank you to our board members, Daniel and Taya, for their hard work organizing this event. As a reminder, this session was recorded and will be available on our website in about a week. And we will be sending out an email to anybody who RSVP'd for feedback on this session. So if you can fill that out, that would be great. And lastly,
I would really appreciate if you can provide feedback, that would be useful for me also, for my work. Yeah.
Fantastic. We will share those feedback with you as well, Dr. Chamala. And the last things that we want to remind everybody of, some of the other things that PathSig is putting on later this month, is we have a networking 101 session scheduled for next Sunday at October 13. Registration is live on our events and webinar section of our website at virtualpathsig.org. We also have a forensic pathology virtual open house featuring fellowship program directors from around the country on October 26th. This event will be a Q&A style introduction to careers and training in forensic pathology for medical students and residents, and it will be hosted in collaboration with the National Association of Medical Examiners. We also have been keeping an updated list of residency program open houses, complete with event dates, registration links, and program contacts. You can find all of that via our Linktree, social media accounts, and our website. And if you don't already, please follow us on Instagram, X, Facebook, TikTok, and LinkedIn at path_sig. So thank you so much, everyone, for participating, and thank you, Dr. Chamala, for giving this very informational talk.
Thank you for inviting, and keep up the great work. Bye-bye.